So what we've got is 12 volts DC going into the yellow 200 turn, going into a 600 turn with a 5 watt 12 volt light bulb. And so DC shouldn't work, but if you turn the switch fast enough, we can induce a back EMF, or there's a changing magnetic flux in the yellow, which is then induced in the blue, which then creates that. You need basically 12 volts to make that work. You can then talk about changing the core, and if you go to a solid core, basically regardless of how fast that goes, well, you can get a little bit but not as much. From there you can go to leaving it on, and can the pupils lift that up and it becomes a really strong electromagnet. You can then put a compass next to it and then see the magnetic field. Essentially when that's on you can't pull it off, when it's off you can, so that's a little bit interesting. From there you can go to 6 volts AC. At 6 volts AC we've got a step up, it goes, when it's off it doesn't. You can say, well, what happens when you take the core off? And there's less changing magnetic flux, so it doesn't work as much. Put it on and it does, and you're hearing those vibrations, 50 hertz AC. And then if we take that off and put a laminated on, getting dramatically higher changing magnetic flux and a dramatically brighter bulb. And so we're trying to enhance that changing magnetic flux happening between primary and secondary coils.